All right. Good morning and hello. Welcome to our webinar. My name is Michael Lepich, Head of Alliances here at Ascend.
And hey everyone, this is Shohei Naran, Technology Partner Manager at Looker.
And my name is Jove Kwong, Solution Architect at Ascend.
Glad you folks could join us today. As we announced last week, Ascend and Looker have partnered in order to close the gap between data analytics and data engineering. This convergence can be transformative for data teams. So we prepared this webinar to walk you through an introduction and touch some key points of how this partnership works. But first, why is this convergence actually so valuable? Well, in most enterprises, the analyst teams don't have good access to the data lakes. When they try to import big data into their data warehouses, it gets really messy. And when they try to access big data directly, it gets really messy. The solution is data pipelines, which make data lakes manageable, but they're usually not usable by analysts. So enter Ascend, which does make pipelines usable by analysts, and now add the Looker Ascend integration, which makes pipelines directly queryable from Looker. So we're here to talk about how this works. For those who are not familiar with us yet, just a quick catchphrase here. Since 2015, we've developed the first unified data engineering platform, which automates and optimizes the complete lifecycle of modern data pipelines. For our customers, this leads to over 10 times faster pipeline creation, 95% less code and maintenance, and significant savings in the running costs of pipelines. So how do we realize these remarkable levels of benefits? To explain this, we have to get into the inner workings of the data teams in most enterprises today. What you'll find is that data analysis and data engineering are two very different jobs, skills, and functions. So while data analysis came into its own with the emergence of data warehouses, business intelligence, and ETL tools, data engineering as a competence came to the fore more recently with the rise of big data and the need to write custom code to work with it. So let's compare these two capabilities. First, analysts have data warehousing and ETL training, while data engineers have data lake and pipeline training. Second, analysts have good SQL skills, while data engineers have good software development skills. Third, analysts are closer to the business and insight requirements, while data engineers have deep understanding of data formats and structures. Fourth, analysts know what they need from the data, while data engineers know how to clear the weeds around the data. So definitely these two profiles have very different skills, tasks, and objectives. They also have very different technology domains. Usually data engineers quickly understand the benefits of Ascend for the pipeline automation, sophistication, usability, and scalability, which we'll talk about. But today we're here to talk about data analysts. The combination of Ascend and Looker significantly expands the data universe of analysts in three important ways. The first is that data pipelines now look like a database. Very familiar to data analysts. The second is that analysts can now use data previously trapped in data lakes. And the third is that analysts can actually build their own ETL pipelines. You've probably heard similar claims before, but the Ascend-Looker combination changes the game. To get us started, let's do a quick recap of the enterprise data universe. When databases first appeared as part of applications that generated well-structured transaction data, data warehousing arose to help create value from the data after the transactions were done. This area keeps innovating around performance, scale, automation, and ease of use. Looker is one of those innovations as it changes how enterprises can actually use data. We'll talk more about that later. Later, the rise of the internet, mobile, IoT, and APIs created a parallel world of big data with its own tooling and platforms. This tooling falls into two layers, one for storage and processing, with Spark and its variants now dominating, and one for orchestration of this data processing in the form of scripting tools. Ascend fits in this world at the orchestration layer, bringing in a brand new level of automation. It can run either in an enterprise VPC with its own processing and storage, or it can be used as SaaS, where Ascend owns and runs its infrastructure for you. Also, data warehouses are often recipients of the output of data pipelines, no problem. Also, this world of data lakes and pipelines is also the native home of machine learning and data science. So these two macro trends of data warehousing and data lakes harbor two common misconceptions we want to talk about today. The first one is the implications of big data with data warehouses. And the second is implications of data lakes without pipelines. Let's go through these one after the other. The first misconception is that modern data warehouses make data lakes obsolete. Data warehouses have powerful ETL capabilities, but they're no substitute for big data and pipelines. Let's go through 4 important considerations as you balance these two capabilities. Yes, dropping big data directly into data warehouses makes the raw data available to analysts. But to use it, analysts now have to really know the schemas of the raw source systems. In big data, these vary widely, they change frequently, and are pretty difficult to interpret. They're not clean, relationally structured tables. They're CSV files, PDFs sometimes, JSON, and often far more cryptic formats. To use this data, one often needs to read the code of the application that generated it. This is the world of data engineers reappearing inside the data warehouse. Second, yes, data warehouses have powerful ETL capabilities, or shall we say ELT, load and then transform inside the data warehouse. Yet the code it takes for these engines to process the data ends up being very complex, running thousands of lines in each stored procedure. Such code breaks as soon as a single element in the schema changes, which it does. Big data has no relational integrity or other constraints, so a routine update, say to a mobile app upstream, can easily cause all downstream ETL to grind to a halt. Third is a common benefit for data warehouses is that they don't need much data engineering to run. This is true. But since they don't solve for the complexity inherent in big data, the work simply falls to the analysts. But data analysts are typically skilled at SQL-oriented logic, so tackling big data software development can really impact their productivity. And fourth, a big benefit of cloud data warehouses is their incredible ad hoc query performance. This is true, but the price of that performance is quite high. Properly organized and scheduled, the bulk of big data processing can be done faster on far cheaper infrastructure with pipelines. For these and other reasons, big data and data lakes are just as critical for business and coexist with data warehouses. They both have important roles in the enterprise data universe. The second misconception is that data lakes can be run without data pipelines. Let's take a look at this. Data lakes without pipelines do have a few benefits, but with dark consequences. Yes, they are incredibly cheap to stand up, especially in the cloud, and need no design to turn on and start accepting data. However, without pipelines, they quickly turn into data swamps with no designations for sources of truth, no governance of any kind, and no tracking of lineage as engineers write code to extract insights for the questions they're asked to solve. The consequences are confusion and mistakes for the business. Second, yes, because they are so cheap, data lakes can accumulate vast troves of data without needing to know what will be useful to whom. However, the enterprise quickly ends up with a culture of every analyst and data scientist for themselves, guessing what data might be useful for their query. With no frameworks in place, it becomes impossible to trace what is being used by whom for what purpose. Third, since data lakes don't impose any structure, they're perfectly resilient to changes in data, APIs, schemas, and upstream applications. However, without any capacity to trace what changes affect which code and downstream usage of the data team is soon consumed with the maintenance of existing code, trying to keep things running. And finally, the low initial cost of data lakes is also a trap, since to get any value out of it requires highly skilled engineers with specific software development skills focused on the many aspects of big data. Without automation, their productivity suffers and disillusionment can grow. So for these and other reasons we'll discuss next, it turns out that the solution for efficient and effective data lakes is highly automated data pipelines. So while pipelines have so far been difficult to build and manage, they've been the quintessential framework for the management of big data and data lakes. Today, we'll give a taste of how Ascend simplifies pipelines so that data analysts can self-service them, and how the integration with Looker means live data pipelines can now be queried directly by data analysts. We believe this will help enterprise teams improve ROI, productivity, quality of insights, consistency of data, and increase of democratization of data across the enterprise. So why didn't this happen before? Let's take a closer look at the data value chain in a data lake with pipelines. This diagram is the same as before, just zoomed in on the data lake landscape of enterprise data. Transactions data still primarily flows to data warehouses, where it's used for business intelligence and analytics. Sometimes data lakes are also used for some transactional data, especially when packaged in less relational formats like spreadsheets. In today's world of data lakes, rudimentary orchestration tools can schedule jobs and move parts of data from one place to another. But to do any work at all, data engineers have to write code. Basic functions like detecting new data, reformatting data, tracking dependencies, optimizing the processing, handling errors, all need to be stitched by hand. Persisting the data, deduplication, logs to be able to audit data, managing space, deleting garbage, controlling access, and other forms of governance is all built into code by engineers. These are just a few of the features that good data pipelines need. Finally, in the middle of all this handling, wrangling, and tracking code, there are also the nuggets, the actual business logic, making sense of the data and deriving insights from it step by step. For most of our customers who have built pipelines before, about 95% of the code is actually not data logic at all. Several studies by experts in the field have confirmed this, and this is where Ascend comes in. Since 2015, Ascend engineers have been building a general framework to run data pipelines. Ascend's unified data engineering platform anticipates and implements all these requirements of building and running data pipelines out of the box. That means 95% of the problem is solved. The only thing it can't anticipate is the 5% of business logic that the pipelines will be used for. So the platform makes that 5% of effort so accessible that data analysts can configure data pipelines themselves using SQL or Python, PySpark, or YAML, whatever their skills are. Ascend does everything else. It ingests the data automatically, it builds the pipeline automatically, it autonomously integrates them into the available infrastructure and data landscape, and constantly monitors and optimizes the pipelines as they run continuously. The platform is data aware, meaning it constantly inspects the data as it flows, looking for gaps, new arrivals, changes, errors, velocity, delays, and responds to it, either automatically making adjustments to bring the system back on track, or raising precise notifications pinpointing the problem. The result is a new data pipeline paradigm, accessible for data analysts to build data pipelines themselves. Ascend maintains order with automated governance across the logic layer, as well as the processing and infrastructure layers, providing full coverage for the pipeline and data lake environments. Check out our press release of March 24th for details about these automated governance features inherent in the platform. With today's partnership and integration, Ascend pipelines can now be queried directly from Looker, making these data sources directly available to analysts, data scientists, and applications. In closing, Ascend makes data pipelines and data lakes accessible to analysts with an end-to-end lifecycle. So, the result is that the design work on the platform is transparent across all teams, subject to strict controls and user management, with hundreds of guardrails to prevent errors. The platform operation is autonomous, steered by configurations with fully automated data governance. And querying Ascend occurs either through the new Looker integration, or as usual, by dropping the data into the data warehouse, minus the garbage of the big data that Ascend manages under the hood. So before we demonstrate Looker and Ascend working together live, let's take a quick look at how the two fit together. Over to Shoei.
Yeah, so just to reiterate one key piece of background that Michael's been talking about in his slides, data technology has changed tremendously, right? And that's obviously true over the last 20 years, from the years of Oracle and SAP, but even over the last 5 years, it's true with companies like Ascend, changing how we approach data in the first place. And it used to be that databases were very expensive, they were very slow, probably lived in your data center, and those facts define the way that businesses use data. But fortunately, that's not true anymore. Databases and pipelines today are incredibly fast. They're cheap. Lots of them live in the cloud. They're super easy to access. And that means that those old constraints no longer apply. And it's a whole new world out there. But here's the thing. Even though databases and data lakes have evolved, analytics tools have not, unfortunately. They're still stuck in that world of slow, expensive databases, and that prevents companies from getting the value they want from their data. And so in the next slide, we see over and over when we talk to our customers that this causes one of two problems, or maybe even both, depending on what kind of organizational structure you have. One thing we see all the time is a terrible data bottleneck on the left-hand side of this slide here. And there's only one team or sometimes one person or maybe a few people that can access the data you need. So every question has to go through them. So every time they need to get data, they get in line. But this is terribly frustrating for obviously the people in line, but also it's frustrating for the analysts too, because they have better things to do than writing the same SQL over and over again. And what happens is people stand in line once, they may stand in line twice, and by the third time, they're sick of waiting. They just go make their decisions they have to make without actually getting the data they need. Now, on the other hand, on the right-hand side here, usually because people get fed up with the bottleneck, is data chaos. People slice off or extract the data that's most relevant to them, whatever they can get their hands on. Maybe they're in finance, and they save a bit of finance data on their laptop, and they do the analysis themselves. And this seems better because at least they're not waiting in line, and everything's fine until they get in a meeting with someone from another department. And that person has a totally different analysis done on supposedly the same data. And with that, the whole meeting, instead of making strategy or making decisions, is spent trying to debug these analyses, right? To figure out who has the right answer in the first place. Now, what you want is the best of both worlds. You want all the trustworthiness that comes with everyone using standardized definitions of your business metrics, but without losing the ability for people to self-serve, to answer their own questions with data. Because fundamentally, right, you want to enable everyone to make better decisions with data, but that's only going to happen if everyone can ask questions of that data and get reliable and correct answers without waiting in line. Now, the problem is companies using old tools simply can't find that middle ground, and that's where Looker comes in. So these three concepts here that I'll go through will be pretty important. And the first thing is that Looker and Ascend act as your single source of truth, empowering your users. Looker, unlike other tools out there, doesn't extract any data from Ascend. All the data cleansing work and the analytics queries, the actual execution of them, take place in Ascend. That means that you have access to all the data, not just a subset downloaded in an Excel file. And you can analyze it in as real time as the data gets piped. It also means your results will return as fast as Ascend can execute them, compared to other analytics tools that upload data into their own, quote, in-memory server that ends up becoming yet another bottleneck. Secondly, Looker standardizes how queries are structured. Just because you open up direct access to a database doesn't mean you've solved the self-service problem. Without data governance and rules on how to write queries and how to execute them, you'll end up with data chaos without any consistent or reliable results you can use for decision making. And that's why we've created LookML, the Look modeling language, for business logic to declare and curate things like table relationships, what tables to pull in, how they should join, how you should aggregate fields, and other business critical calculations. And last but not least, the Looker platform is built to let everyone in a company get access to the data they need. Now, in many circumstances, a BI tool is not where people need data. The fact that Looker is a web application with API coverage means that you can leverage data definitions and access it anywhere, from embedded reports in maybe your internal application or external facing apps to building custom applications with our API. It also makes it easier to build workflow solutions, not just visualizations, with third-party integrations. And by taking this approach, you're able to avoid the pitfalls companies tend to face when implementing new data stacks. First of all, since Looker executes queries right on Ascend's data pipeline and target warehouse, you'll have access to all the data in one place without creating duplicate databases and duplicate storage costs on the BI side. In addition, Looker doesn't end up as a bottleneck, since our queries are as fast as the data warehouses and pipelines themselves. Then that leads to the possibility of real-time analysis, since Ascend not only allows users to query the end result tables, but also intermediary ones. Users can now access data as they become available throughout the process, rather than waiting until the very end. And finally, since the stack allows access to the rawest data and to pristinely manage data across all sources being piped through Ascend directly on Ascend, you won't have any manual Excel munging or reports with stale data floating offline. And here's a diagram putting this all together. At the bottom, we have, let's say, customers trying to centralize all their data into a data warehouse. Looker, in purple, connects directly to this data warehouse to model how to structure queries and execute them on the warehouse itself. Once you've standardized data definitions, you can use that in a more or less traditional BI way in conducting internal analytics and visualizing your data. But we know that's not the only way users want to use data. Often, it's best to bring your data to where it's needed by maybe embedding reports or dashboards into other applications, maybe in your internal Salesforce instance. Or it could be a scheduled report sent to a team's inbox on a certain frequency, a secure storage location, and more. And Looker's REST API allows developers to build completely new data experiences as well, from workflow integrations to custom applications powered by Looker behind the scenes. And Ascend expands on the structure by introducing real-time pipelines into the mix. And the great thing about Ascend is that it acts as both the pipeline as well as the end warehouse. So you can see how your data gets cleansed at each step, use intermediary results in your decision-making, and of course, using the end result as tables for organization-wide analytics, for self-service analytics with good data governance. And this new integration makes it possible for Looker to query pipelines just like a database, closing the gap between BI and big data. And the result is that data previously trapped in messy lakes and behind cryptic black boxes, if you will, are now directly available to the Looker user. And with that, I think we can move over to the demo portion. What we'll do is I'll give you a quick tour of the Looker GUI and how that relates to Ascend, and introduce you to the data set that we're using. And once we do that, we can pop on over to the Ascend side and actually take a look at how the data was created in the first place. Now, the one thing that, again, I want to reiterate is the fact that Looker is not taking any of the data from Ascend. This is our very dry but important connection settings panel. And all I want to show you is the fact that we are connected to the Ascend host using Spark. It's a JDBC connection, and that's that. No data extraction happening, which means whenever you connect to these data warehouses, you can start analyzing data immediately instead of waiting for a batch upload of data. There. And so the data that we're using today is New York City taxi data, and we've actually filtered on only rainy days, and that's done in Ascend. We'll talk about that a little bit later. But that's why you see, let's see, if you take a look at this tile here, average tips versus average total fare on rainy days, you'll see some gaps. And those are non-rainy days, sunny or cloudy, just not rainy. Now, all of this data, or I should say result set, came straight from Ascend. So anything that we're looking at was once a SQL query that got executed on the Ascend side, and we were able to visualize it and put it onto a dashboard. And creating visualizations, creating dashboards are great. That's always a great starting point, but that shouldn't be your end goal. The end goal is to take this data set and actually take action on it, or to dig deeper into what happened. So let's take a look at average tips versus average total fare on rainy days once again. And one more thing that I want to note here is that we're only looking at data up until February 23rd. And you'll notice that's the case with other tiles as well. The 23rd is the last date that we have in the Ascend pipeline. So coming up to this tile once again, I noticed that I would say this date here, the 24th of January, has most likely the highest average ride amount, your fare, if you will. And I'd like to know if that's the case because there was one particularly large fare that skewed everything, or maybe there was a succession of fares, of rides that ended up taking a longer amount of time, longer distance. So I'd like to understand what's going on here. And Looker, since everything gets reduced into a SQL query that gets executed on the data engine side, we can actually click on that particular number. And we can see what happened at a row by row level. So we're getting really granular to each and every single ride that happened on that day, right? And this is fine. If you're maybe running machine learning and you like to predict certain outcomes, you can download this result set, or even siphon it off using our API and dump it into another machine learning platform. But as a data analyst, what I like to do is to make sense of this data. And right now, the data is a little bit too granular. So what I'm going to do is to further explore this data. And that takes us over to the Explore section, as we call it. This is our ad hoc self-service data workstation, if you will. So again, we have that data set that we were just looking at, and we have a whole bunch of things that we can choose from, right? Different fields. It seems like we have some averages and totals. These are all the fields that we can pull in to reanalyze this data. But the one thing that I want to show you is if you click on SQL, you'll see exactly what Looker wrote in order to get that result set. So Looker will never be your black box, right? You can always audit and make sure what Looker is writing. And another thing is, above and beyond just looking at what Looker wrote, you can be assured that whenever somebody clicks on these fields, Looker writes consistent SQL. So no matter who you are, no matter what the tech skill set you have, you're going to get consistent results, and therefore self-service, in the truest sense of the term, becomes possible. So let me do this. I'm looking at timestamps, and I'm not sure I want to look at data second by second or minute by minute. So in fact, what I'll do is I will start to remove a lot of these fields, like vendor ID. Let's actually take a look at the different cab types and see if there's a difference. Click on Run. Great. So it seems like we only have the green cab type. That's fine. on any other day and any other tool, you might have looked at this and said, that's a little wonky. I'm not sure if I can trust this data. How do we even get this? But in Looker, you can see exactly what Looker wrote in order to get the results set. And now that I'm looking at this, I'll say, well, you know, that's not really giving me too much information. Maybe I should take a look at the hour of day. On the 24th, which hour from midnight to 11 p.m. did we have the most number of rides, or did we have the highest average fare? So that's exactly what I'm going to do. There. And with a little bit of sorting, you get a chart that looks like this. And surprisingly, it's the 5 a.m. trips that have the highest average fare amount. So maybe people are staggering home from their late night out, or they're getting ready to commute. But in any case, that's what Looker allows end users to do. You can report and create dashboards, use our API, but most importantly, whatever analytics you work on in Looker is consistent and reliable because we've governed how to access the data source, in this case is Ascend. And with that, I'd like to pass it over to Joe, who will walk you through how the data pipeline was created in the first place.
Thanks, Shohei. Let me get my screen share going. Okay. What I'm showing on my screen now is the data flow in Ascend that monitors an S3 bucket containing the CSV files for NYC taxi trip records dataset, as well as the NOA weather API. This data flow now also performs a series of transformations on the dataset, such as union, join, filter, and aggregations. The rainy day taxi rides dataset Shohei was working on, we saw earlier in Looker, is created by this particular transform. Just like you see from Looker, this transform is similar to a table in your database, even though under the hood, it's just one stop in a Spark-based data pipeline. We'll talk more about that later. Now, as we saw earlier in Looker, this data flow only contains January and February data right now. With Ascend's data aware system, the data flow monitors for new data arrival in S3 and refreshes autonomously to keep the dashboard in Looker fresh with new data. So to demonstrate that, I'm now going to add an additional CSV file in S3 that contains trip records from the first 3 days in March. I'm going to complete this upload through the AWS console. So as this process completes, once we see the file ends up in S3, I'm also going to refresh the rig connector in Ascend. So the file is now there. Now let me get back to Ascend, and I'm going to refresh this particular rig connector in Ascend. So in production, the rig connector is usually automated to refresh on a configure schedule, so manual refresh won't be necessary. Looking at the status indicator of the rig connector, we can now see Ascend has detected the new data file and also completed processing the new data file incrementally already and started to propagate the data incrementally through the data flow. As this is now running, I would like to explain in details how automatic incremental processing is possible in Ascend with the data aware system. So let me open up this partition tab. Here is where Ascend keeps track of every single S3 file in the system that has been processed as a data partition. Then for each file, or we can call them data partitions, Ascend uses the object path as the partition name so that Ascend can automatically identify which file is added or removed. And we can also see the file we just added to S3 as well at the bottom here. In addition, Ascend also uses the E tag as the partition signature so that Ascend can automatically identify which file is changed. As a result, Ascend is able to process the S3 files incrementally out of the box by only processing those that are new, removed, or updated. Some of our customers are managing millions of partitions a day this way, completely automated. Lastly, we use S3 as an example here, but Ascend's data aware system works with any data repositories and any data formats. For example, that's the weather data from the NOA web API. Instead of the object path, we simply use the month embedded in the data itself to identify the data partitions. Now that Ascend connects to the data source through the RIG connectors, Ascend also offers a built-in ad hoc query interface powered by Spark for me to explore the data set. Let me quickly tick the UI there. So this feature supports the analyst during the design process of the pipeline to immediately see the live data in the system to be able to adjust and revise on the spot to get the desired results. So for example, let me run a live query here to get back all the HOV chip records from the yellow cap dataset with passenger counts greater than 5. Once I'm satisfied with the results, I can create a transform in the data flow to represent this transformation step. The transform are similar to a table in the database again, but here we're working with big data, right? So let me get this transform created as well in our system. And Ascend intelligently persisted the data incrementally in Snappy Parquet format with Spark as I created the transform. So this transform now is part of the data pipeline, and we don't need to do anything else to keep it fresh. Ascend's autonomous engine takes over from here, creating the Spark jobs, scaling infrastructure, tracking the changes, persisting the results along the way, both for the initial backfill as well as the incremental processing going forward. No additional coding is needed. So right after I created this transform, I actually realized this is a production data flow and I'm not supposed to make changes, and I should make changes in my own dev branch instead. So to do that, I am now going to select and export a subset of this data flow by only choosing these couple components. And I'm going to export them. So once I have the export, I can now delete the transform I accidentally created in the production data flow. I'm now ready to create my own dev version. So let me create a new data flow, and I'm going to name this dev Jove. And now I can import the subset we just exported into my own dev branch. Let me put the creds in here and start importing. So two things I want to call out here. First, Ascend is a data aware system, so it does not create a copy of the data when I do this, but instead, it simply references the new dev branch to the same underlying data set. As a result, you see everything is up to date right away. Secondly, everything I just did can be done through the command line as well, so that I can work with Git or my favorite version control system, so that I can keep track of the branch in my version control repository as well. Now I have my own dev branch. I actually would like to lock down the dataset to only January and February so that I'm working with a smaller sample dataset. So now I'm going to change the read connector to only capture the first 2 months of 2020. And I'll need to enter the credential again. So even though we make changes to the read connector, but Ascend's data aware system will not reprocess anything because this is essentially a rollback operation. We now see everything becomes up to date instantly again because production has already processed the 2 months data before we edit the March data at the beginning of this demo. So at this point, I have created my dev branch within which I can freely make changes without impacting production. So now let's go back to our production data flow. Ascend is working to keep the data transform fresh by running incremental updates automatically whenever possible, every time the read connector discovers new data, as we saw earlier. For example, let me highlight on this particular transform and take a look at the partitions again. So if we take a look at the start time and completion time of this particular transform, we'll notice that there's only one partition out of the 271 partitions that started just now. Most of the partitions were processed almost 2 weeks ago as we created this data flow. This is to show Ascend has incrementally processed the March data. That's to say this additional partition just now, instead of reprocess all of the data in this particular transform. The other thing I want to point out is all transform logics in Ascend today runs as Spark jobs, fully managed and optimized by Ascend. As a result, users only need to provide the SQL logic, and Ascend will figure out the rest, such as driver, executor, memories, etc. That said, Ascend also allows Spark experts to check out the Spark job UI, for example, just to see exactly what parameters were used, or provide overrides to the Spark job if needed. So the data flow has already been completed. The next thing I want to show is how the system keeps track of sequence of every refresh and how long it took. So in the time range, let's just limit it to the last hour. So in here, this timeline view provides the basis for cost reporting. Ascend calculates how much each of these pipeline costs and run and tracks where they are used, so the business users can make trade-offs about its data investments. Lastly, I also want to point out Ascend can write data out to a data warehouse such as Redshift using what we call the write connector. For example, in this example pipeline, I'm sending the taxi rides versus weather to Redshift. Note in this case, Ascend is still managing the data, including the schema in this external data repository. What that means is if there's upstream has a new column or one less column, Ascend will adjust the schema in this Redshift table automatically so that the Redshift table match exactly, not just from a data perspective, but also the schemas to the upstream transform. So now that the entire data flow has been up to date, we now have March data propagated everywhere. Shohei, do you want to take a look at the March data through the Looker dashboard?
Yep, sounds good. Let me then show my screen here. Okay, so as Jove mentioned, we should have access to March data. And again, just to clarify, we were only looking at data up until the 23rd of February. So what I can do now is clear cache and refresh, see what happens. So we're going straight to Ascend and querying the data there. Again, there's no data extraction that's happening. No data is being pulled into a Looker database because that just doesn't exist. And there we have it. We've got more data for rainy days in March, perhaps only 2 days in March so far. But this is the kind of real-time sync that happens between Looker and the data lake or data pipeline that is Ascend. And what's great about this is that now you have full control over the governance of business logic, right? How you want to access the database, as well as the data itself. Because Ascend can easily roll back data. So for example, if somebody made a mistake, let's say in creating the data pipeline, or they didn't upload the correct files, the underlying source system was down and things just didn't work out, then it's easy for an Ascend users to roll back that data set to the last known best state. And that's the end of the webinar today, including the demo. But what I wanted to say to all of you is thank you so much for taking an hour of your day. And if you'd like to learn more about Looker or Ascend, if you'd like to have a detailed demo of Looker or even start a trial, don't hesitate to reach out to sales@looker.com.
Thank you, everybody, for participating today. Really glad to see you. And to check out Ascend, go check out our trial online at ascend.io/trial and get started. There's some credits there, and looking forward to seeing you there. Have a great day.